welcome to the Deep Dive. Today, we're taking a fascinating journey through our cosmic neighborhood, the planets of our solar system.
It's an incredible collection of worlds, absolutely. Each one with its own unique story, really. And you're right, there's just so much information out there, it can feel a bit much sometimes.
Totally. So, our mission today, if you like, is to be your guides through this planetary landscape. We want to hit the highlights, the most compelling bits and key discoveries about each of the 8 major planets.
Think of it as a shortcut.
Exactly. A shortcut to getting, properly informed about what's orbiting our sun without getting bogged down.
And maybe before we dive in, it's useful to remember that basic split in the family, right? You've got the inner, smaller, rocky planets.
Mercury, Venus, Earth, Mars.
Right. And then the outer, much bigger siblings, the gas and ice giants.
Jupiter, Saturn, Uranus, and Neptune. Got it.
Precisely.
Okay, let's unpack this. Starting close to home, well, close to the sun anyway. Mercury. Tiny little thing, relatively speaking.
Yeah, it's small. Diameter about, 4,880 kilometers. And it really hugs the sun. Average distance, maybe 58 million kilometers.
Which is less than half the Earth's distance, like 0.39 AU.
Right. And being that close obviously shapes everything about it. What's interesting is, despite all that solar radiation, it barely holds onto an atmosphere.
It has that exosphere thing.
Exactly. An exosphere. Think of it like a super, super thin veil of gas. Oxygen, sodium, hydrogen, helium, potassium. But the molecules are so spread out, they almost never collide.
Okay, so definitely not breathable. And that lack of atmosphere plus no real geology happening anymore.
Means the surface is just covered in craters. Looks a lot like our moon, actually.
Why is that? Just getting pummeled constantly?
Well, yeah. Without a thick atmosphere to burn up meteors and no volcanoes or, plate tectonics to pave over the old impact.
Big craters just stick around for billions of years.
Yeah.
Makes sense. And no moons either.
None at all. Which is a bit unusual for a planet, even a small one.
And the temperatures.
Ah.
Wow. Talk about extremes.
Oh, absolutely. Because it's so close to the sun and has that thin, thin atmosphere, the sunny side can hit 427 Celsius.
Boiling.
And then the night side plunges down to minus 173 Celsius.
That's a swing of, 600 degrees? Mind-boggling.
It's seriously extreme, but we have sent probes there.
Right, Mariner 10.
Mariner 10 flew by back in the 70s. Then Messenger orbited for years, gave us amazing data until 2015.
And isn't there one on the way now? Bepi Colombo?
That's the one. A joint European and Japanese mission. It's en route right now. Should tell us even more.
Something else I found fascinating, its orbit. It's the most eccentric. What does that mean exactly?
Eccentric just means its orbit isn't a perfect circle, it's more of an oval. And Mercury's is quite a stretched out oval compared to the other planets.
Well, sometimes it's much closer to the sun, sometimes further away.
Exactly. Its distance varies quite a bit during its year. And another weird thing, it has a huge iron core for its size.
A massive core in a tiny planet. How does that happen?
Well, the leading theory is pretty dramatic. Maybe, early on, it got hit by another big protoplanet.
A giant smash-up.
Could be. Something that stripped away a lot of its outer rocky layers, leaving behind mostly the heavy, dense core. It's still debated, though.
Wow. Okay, cosmic billiards. Let's move outwards to Venus. Earth's sister planet, they sometimes call it.
Yeah, similar size, roughly 12,100 kilometers across, and orbits around 108 million kilometers out. So size-wise, very similar to Earth.
But that's where the similarities end, right? The atmosphere is something.
Oh, it's hellish. Seriously.
Yeah.
Incredibly dense, like 90 times Earth's surface pressure, and almost all carbon dioxide.
With clouds of sulfuric acid. Yikes.
Yep. And all that Kyoros creates this runaway greenhouse effect.
We hear about the greenhouse effect on Earth, but this is like off the charts.
Completely. On Earth, it keeps us warm enough for liquid water. On Venus, that thick Kyoros blanket just traps heat relentlessly. Catastrophic warming.
So what does that do to the surface temperature? Is it hotter than Mercury even?
It is. Average surface temp is about 464 Celsius. Hot enough to melt lead.
Whoa!
And unlike Mercury, with its big day-night swings, Venus's thick atmosphere spreads the heat around. It's pretty much that hot everywhere, day and night.
Crazy. But does anything happen on the surface? Volcanoes, mountains?
Oh, yeah. We see vast volcanic plains, some mountains that look like they've been crumpled up, suggesting some kind of tectonic activity, though maybe not plates like Earth's, and impact craters, too. But like Mercury, No moons.
Exploring it must be incredibly tough.
Extremely. The Soviets managed it with their Venerla landers back in the day. Amazing achievement, really, given the conditions.
They actually landed.
Landed and sent back data before being crushed and cooked. Then NASA's Magellan orbiter used radar to map the surface through the clouds. And Japan's Akatsuki is studying the atmosphere now.
Venus also spins weirdly, doesn't it?
It does two really odd things. First, it spins backward compared to most planets, retrograde rotation.
So the sun rises in the west.
If you could see it through the clouds, yes. And second, it spins incredibly slowly. One Venus day is actually longer than its year. It takes about 243 Earth days to rotate once.
Longer day than year. That's just bizarre.
Venus is definitely the solar system's oddball when it comes to rotation.
Okay, next up, home sweet home. Earth, we know it well, but let's put it in context. Diameter around 12,742 kilometers. Orbiting at that perfect 1 AU, 150 million kilometers or so.
And our atmosphere, well, it's just right for us, isn't it? Mostly nitrogen, good chunk of oxygen, vital trace gases. It's what allows life as we know it.
Plus the surface is mostly water, about 71%. And it's so dynamic. Geology, climate, always changing.
Absolutely. We've got plate tectonics, shifting continents, building mountains, causing quakes. We have weather driven by the sun and oceans, active volcanoes. It's a very lively planet.
And we have our moon, of course, one big one.
Which is pretty significant. Stabilizes our tilt, drives tides. That's important.
And temperature-wise, that average of 15 Celsius seems so comfortable compared to Mercury and Venus.
It's the sweet spot, isn't it? Allows liquid water on the surface, which seems key for life.
And we've explored Earth, well, constantly. Satellites, telescopes, people crawling all over it.
We have an unbelievable amount of data about our own planet, naturally.
And the really unique thing, the thing that sets us apart as far as we know,
is life. Earth is the only place we know for sure that harbors life.
It's profound when you think about it.
It really is. Makes
Yeah.
you wonder what it takes and if those conditions exist elsewhere.
Okay, moving outward again. To Mars, the red planet.
Yep. Noticeably smaller than Earth, about half the diameter, maybe 6,800 kilometers across, orbiting further out to around 1.5 AU, 228 million kilometers.
And that red color comes from rust, basically.
Iron oxide, yeah. Lots of it in the dust and rocks. And its atmosphere's thin, much thinner than Earth's. Mostly carbon dioxide again, but not thick like Venus's.
But the surface tells a story of a different past, right? Giant volcanoes, canyons.
Oh yeah, Olympus Mons, the biggest volcano in the whole solar system. It's enormous. And Valles Marineris, a canyon system that dwarfs the Grand Canyon, suggests Mars was much more geologically active long ago.
And it has moons.
Two tiny ones, Phobos and Deimos. Probably captured asteroids. They look like potatoes.
What about Martian temperatures? Cold, right?
Generally very cold, yes. It can range from minus 125 C at the poles up to maybe 20 C near the equator in summer.
20 C. It's not bad. Could water exist?
But the air pressure is so low, liquid water on the surface now would just boil away or freeze almost instantly. It's not stable.
But Mars gets so much attention from explorers, rovers everywhere. Why the fascination?
You're right. There's a constant stream of missions. Viking, back in the 70s, then Curiosity, Perseverance, China's The Wrong, Insight. It's a huge international effort.
It's all about the L word, isn't it? Life.
Largely, yes. The big unique feature, the driving question, is whether Mars ever supported life, or maybe still does, hidden somewhere.
Because there's evidence of ancient water.
Lots of it. Features that look exactly like dried up riverbeds, lake beds, deltas. So the conditions might have been right billions of years ago. Finding proof of past habitability, maybe even actual signs of past life biosignatures, that's the holy grail.
Okay, fascinating stuff. We've done the inner rocky worlds. Now, into the realm of the giants, starting with the king, Jupiter.
The undisputed king, yeah, it's just massive. Diameter almost 140,000 kilometers, orbiting way out there, 5.2 AU, around 778 million kilometers from the sun.
And it's a gas giant, so no solid surface to stand on.
Nope, it's mostly hydrogen and helium, like the sun.
Yeah.
What we see are the cloud tops, ammonia, water ice, other compounds making those distinct, colorful bands and swirls.
So if you tried to land, you just fall.
You'd just keep falling, yeah. And the pressure and temperature would get higher and higher. Deep inside, the hydrogen probably becomes metallic because the pressure is so immense.
Metallic hydrogen.
Wild.
And moons. Jupiter has loads of them, right?
Loads. Over 95 confirmed now. But the four big ones, the Galilean moons discovered by Galileo, are the most famous. Io, Europa, Ganymede, Callisto.
And Europa's the one with the potential ocean.
That's the one. Strong evidence for a huge saltwater ocean hidden under its icy shell, which makes it super interesting for potential life.
Any others?
Io is incredibly volcanic, just spewing sulfur constantly. Ganymede is the biggest moon in the solar system, bigger than Mercury, and has its own magnetic field. Callisto is old and heavily cratered. They're all unique worlds.
And Jupiter itself, despite all that internal action, is cold at the cloud tops.
Yeah, about minus 145 Celsius up there.
We've been sending probes there for a while, too.
We have. Pioneer and Voyager did the first flybys. Galileo orbited for years, studied the whole system. And right now, Juno is orbiting, diving close to study its gravity, magnetic field, and deep interior.
That magnetic field is powerful, I hear.
Extremely powerful, generated by that metallic hydrogen layer swirling around due to Jupiter's fast rotation.
And you can't talk about Jupiter without mentioning the Great Red Spot. What is that thing?
It's basically a giant persistent storm, an anticyclone, a high-pressure system that's bigger than Earth.
Bigger than Earth.
Yep. And it's been observed for centuries. We still don't know exactly why it's lasted so long, but it's a stunning feature.
Okay, from the king to the jewel of the solar system, Saturn.
Saturn, second largest, diameter around 116,000 kilometers, orbiting way out at 9.5 AU, roughly 1.4 billion kilometers.
Another gas giant, mostly hydrogen and helium.
That's right, no solid surface. It has atmospheric bands too, but they tend to look a bit more hazy, less contrasty than Jupiter's. But obviously Saturn's all about the rings.
The rings, they're just incredible. What are they made of? Ice?
Mostly water ice, yeah. Countless particles, from tiny dust specks up to chunks the size of houses, maybe even small mountains.
And they're not solid disks.
Not at all. It's this incredibly complex system of individual rings and gaps shaped by gravity, especially the gravity of Saturn's many moons.
Speaking of moons, Saturn has even more than Jupiter now.
The count keeps going up. Over 145 last I checked. And some are really spectacular.
Titan has to be top of the list, right? With an atmosphere.
Absolutely. Titan's unique. It's got a thick, nitrogen-rich atmosphere denser than Earth's, and unbelievably, lakes and rivers of liquid methane and ethane on its surface.
Liquid methane lakes. So alien.
Really is. And then there's Enceladus, a smaller icy moon, shooting plumes of water ice and organic molecules into space from a subsurface ocean.
Another potential ocean world.
Exactly, making it another prime target in the search for life. And Saturn itself is pretty chilly, average temp around minus 178 Celsius.
And the Cassini mission spent a long time there, didn't it?
Oh yes, Cassini was amazing. Orbited Saturn for 13 years, from 2004 to 2017. The data and images it sent back of Saturn, the rings, Titan, Enceladus just revolutionized our understanding.
Those pictures were incredible. Okay, pushing even further out to the ice giants. First up, Uranus.
Uranus, significantly smaller than Jupiter or Saturn, about 50,000 kilometers in diameter, orbiting way out there, 19 AU, almost 3 billion kilometers from the sun.
And it's an ice giant, not gas. What's the difference?
Well, it still has lots of hydrogen and helium, but it also has a much higher proportion of heavier ices, water, ammonia, methane, especially in its interior, probably a hot, dense fluid mantle rather than distinct layers like Jupiter.
And the methane gives it that blue color.
Exactly. Methane gas in its upper atmosphere absorbs red light and reflects blue and green light, giving it that distinctive cyan color.
Moons. Rings.
It has 27 known moons. The 5 main ones are Miranda, Ariel, Umbriel, Titania, and Oberon. And it does have rings, 13 of them, but they're very faint and dark, quite different from Saturn's bright ones.
And it's the coldest.
Yep, holds the record. Average temperature around minus 224 Celsius. Brr.
The weirdest thing about Uranus is how it spins, right? On its side.
That's its most unique feature, definitely. It's tilted over by about 98 degrees, so it's basically rolling around the sun on its side.
How'd that happen? Another cosmic collision.
That's the leading theory. A massive impact early in its history probably knocked it over. It leads to really extreme seasons, with each pole getting like 42 years of continuous sunlight, then 42 years of darkness.
Wow. Have we visited Uranus much?
Not really. Only one spacecraft has ever flown past.
Just one.
Just Voyager 2 back in 1986. So a lot of what we know comes from that single flyby and telescopes.
Okay, last stop on our tour. The outermost planet, Neptune.
Neptune. Very similar in size to Uranus, diameter around 49,000 kilometers, but even further out, orbiting at 30 AU, about 4.5 billion kilometers from the sun.
Another ice giant. Similar composition.
Yes, also an ice giant. Hydrogen, helium, and methane. The methane gives it a much deeper, more vibrant blue color than Uranus, though, and Neptune's atmosphere is surprisingly active.
Active how?
It has incredibly strong winds, the fastest winds recorded anywhere in the solar system, actually.
Faster than Jupiter's storms.
Much faster. Up to 2,100 kilometers per hour. Supersonic winds whipping through that atmosphere. It also had a great dark spot, similar to Jupiter's red spot when Voyager 2 flew by, though it seems to have disappeared since.
Just incredible speeds. What's underneath the clouds?
Similar to Uranus, probably deep layers of water, ammonia, and methane ices. No solid surface. It has 14 known moons.
Any interesting ones?
The largest one, Triton, is really interesting. It orbits Neptune backward.
Backward, like Venus spins backward.
Sort of, but it's the orbit, a retrograde orbit. This strongly suggests Triton wasn't formed with Neptune, but was captured later on, probably a dwarf planet from the Kuiper belt that strayed too close.
A captured world. Does Neptune have rings too?
It does, 5 main rings, but like Uranus's, they're faint and clumpy, hard to see, and its temperature is about minus 218 Celsius, surprisingly a tiny bit warmer than Uranus, even though it's further from the sun, probably has more internal heat.
And like Uranus, only one visitor.
That's right, Voyager 2 again in 1989. It gave us our only close-up look at Neptune and Triton so far.
It's just amazing, isn't it? The sheer variety across just 8 planets. Rocky worlds, gas giants, ice giants.
Absolutely. And our sources kind of summarize this nicely, looking at things comparatively. Type, moons, atmosphere, rings, even surface gravity.
Right, and that comparison really drives home the differences. The little, dense, rocky inner planets with few or no moons and no rings.
Compared to the huge, low-density giants with thick atmospheres, tons of moons, and ring systems. Big contrast.
But even within the groups, there's so much variation. Venus's killer atmosphere versus Mars's thin one, Jupiter's colorful bands versus Saturn's paler look.
Exactly. And the ice giants being distinct again with more methane, different ring structures. It's just a remarkable range of outcomes from planetary formation, all in one system.
It really is mind-blowing. From Venus's furnace to Uranus's deep freeze, rusty Mars to stormy Jupiter, each planet is a whole world with clues about how things form and change out there.
And thinking about all those extremes, the pressures, the temperatures, the weird chemistry, it really makes you question what habitable even means, doesn't it?
Yeah, totally. Could life exist in ways we just can't imagine? In places that seem completely hostile to us?
It's the big question, isn't it? Maybe under the ice of Europa, or Enceladus, or even in the clouds of Venus? Who knows?
Definitely something to ponder. Well, this deep dive has been an incredible tour of our planetary neighbors. So much diversity right here. But clearly, there's always more to find out.
Always more to explore. It's just the beginning, really.
Thanks for joining us on this planetary expedition.